So what do you notice about this graph? The graph's trend is going upwards, and still, again, you can see a portion of that graph as going down. So it's actually concave down. And what else? What else can you say about this graph? It's concave down, and you could also notice that the slope is positive, so it's increasing and also positive. That's how this graph is going on. Okay? So what do you see, or what can you notice? What can we say when our b is in between 0 and 1? For the power function in between 0 and 1, our graph would most likely be like this. So it's increasing to the right. It's positive and increasing. It's concave down. Okay. Now let us investigate the middle function, the middle power function. This is our function. Let's move it a little bit here. So, of course, I will be needing again a table. Of course, we're going to present a table. So we have to pick up our x and y values again. Okay. So this is my table. And this will give me my x and y values. So this is my column for my x, and this is my column for my y. And having the same values of x, let us have 0 to 4. 0, 1, 2, 3, 4. So from 0 to 4, let us examine what the value of y is. If our x is equal to 0, then this one, okay, let me clarify the function for you. So 3x negative 1. So our b here is less than 0 because it's negative 1. Okay, so if x is equal to 0, we would also have 3, 0, negative 1. It is undefined, so we will have a limit at x is equal to 0. We have a vertical asymptote. It wouldn't touch your y-axis. Let us define your y-axis and your x-axis. So this is your x, this is your y, this is your x. If my x is equal to 1, then I would have 3 times 1 raised to negative 1. By the way, that y is equal to 3x raised to negative 1 is also equal to 3 over x. So x couldn't be 0. Why would your x cannot be 0? Because if your x is equal to 0, then we have an undefined value of y. Therefore, we have a vertical asymptote at x, because your x cannot be equal to 0. Okay. If our x is equal to 1, so we just replace your x here with 1, so the answer is 3. And if x is equal to 2, then that would be 3 over 2, or in this case we have 1.5. If our x is equal to 3, we will have 1. If our x is equal to 4, then we would have 3 over 4, or that is 0.75. Okay, so let us move this table a little bit far from here. Okay, that's okay. We would need the grid lines again. So we have the grid lines. We just have to arrange the lines, the axis. So our x-axis and our y-axis. Okay, and we have our y-axis here. So if our x is equal to 1 or 0, then we would have a limit at y is equal to 0. So we would have a vertical asymptote. Now let us make it a little more vivid. So this is your vertical asymptote. And then if it's 1, if x is equal to 1, then our y is equal to 3. So our y is equal to 3. 1, 2, 3. So it's here. If our x is 2, then it's 1.5. So it's here. And if our x is 3, then we would have 1. So it's here. If our x is equal to 4, we would have 0.75. So it's here. And you would also notice, let us take out the grids for a while, that you also have a horizontal asymptote. So aside from this vertical asymptote here, aside from this asymptote here, the vertical asymptote, we also have a horizontal asymptote. So our horizontal asymptote is, now to take the horizontal asymptote, the most common thing that people do is, or technically, okay, to get the horizontal asymptote, just compare the exponent of your denominator and your numerator. Your denominator has an exponent of 1, while in your numerator it has an exponent of 0, because this is actually equal to 3x raised to 0. So therefore you have a vertical asymptote at y is equal to 0. So you cannot touch your y. So let us connect all of the points now. And connecting all of the points, we have asymptotes at x is equal to 0 and y is equal to 0. So we couldn't touch these values wherein there is a broken line. So in other words, in simpler terms, we couldn't touch your x-axis and your y-axis. And in this case, we are going to connect the points now. And our points would somehow lead us to this graph. Your y approaches or this curve approaches the y-axis, but it won't touch your y-axis, okay? And also the same thing with this curve, with this arrow, it wouldn't touch your x-axis. So as you will notice, there are 3 distinct graphs possible for power functions. So if and what are those? If your b is greater than 1, in this case, if your b is greater than 1, let us highlight those conditions. This is the first one. If your b is greater than 1, you would have a graph which is going like that, okay? If your b is less than or in between 0 and 1, okay, such as in this case, then your graph would be something like this, okay? And if your b is less than 0, like in this case, if it's x raised to -2, x -3, and so on and so forth, then you would have an asymptote on your x-axis and your y-axis. And depending on the asymptote, then you would have this graph, which you can see on the middle. Okay? So this is differentiating all of the power functions and the graphs of those power functions. Thank you for watching.